Today, I'll be talking about data ingestion pipelines in Apache Beam. So who am I? I'm a software engineer at ML6, which is a company in Europe, and we specialize in everything AI and ML. So we do strategic advice, data governance, and so on. We also do end-to-end implementations of custom applications, all related to ML and AI. Can be like a quality inspection using computer vision, but also a lot of NLP-related applications. So I made this talk together with Konstantin, who's also here. We can talk to later. So what will we cover in this talk? I will first give you a small introduction to RAG, just to get everybody on the same page. I know you probably have heard of it, but it's probably good to go over what it is. And then we're going to go over the steps that we took to build an ingestion pipeline, and then some final remarks. So first of all, RAG, what is it? A RAG is a process where we are going to ask an LLM a given question or to solve something for us. But instead of directly asking it and having it to rely on its data that it's been trained on, we're going to supply that LLM in the prompt with some extra data, with some extra documentation, with some extra documents, so that it can base its answer on that information, which can be then more factual, or it can give it information that's not been trained on, that is private within your organization. To do that, give that information to the LLM, you need to have some sort of retrieval part. And the retrieval part can be anything. The simplest way is a lexical search, where you're going to do like keywords. So you have a search query, you're going to look in your database, which of the documents contain those keywords, and you're going to return those. But when interacting with LLMs, we usually do it via a natural, like talking way. Like we have these chat interfaces, like ChatGPT and so on. And keyword search is not ideal. So you want to have something, we want to search for meaning. And therefore, we're going to use semantic search. And semantic search relies on text embeddings, which is basically a numerical representation of text. How do we get that? Well, there are special machine learning models, embedding models, that can convert a piece of text into a vector representation, as you can see. And you're not going to do this completely random. You're going to do this in such a way that when you have a bunch of embeddings generated by that model, the ones that have a meaning that is related to each other are close to each other in the vector space. The ones that have no relation to each other are further apart in the vector space. And semantic search then will get a query. We're going to embed that query as well. And then we're going to do a nearest neighbor search in the embedding space. And that way we don't have to let the user guess for exact keywords, but we can have a more natural conversation with the AI. These vectors, they are typically stored in a vector database, which is a special database which has optimized structures to do fast nearest neighbors lookups. There's a bunch of them on the market. Some of them are more like relational. Some of them are very much like JSON databases. You can look it up on the internet. There's a lot of comparisons between a lot of them. It doesn't necessarily matter a lot which one you use for RAG. Just know that we have like a specialized database typically in use. Maybe a little bit on what makes a good embedding. In a good embedding, we don't want to put too much text, so we can't just drop a 20-page PDF in it. Why is that? It's really hard for the model then to sort of get that understanding of what the text means and get those relations between different embeddings. But we also can't too little information. So there's like some parts in the text that have context that can be really important for your embedding. And to do that, people have come up with a lot of different techniques, chunking being the main one. So what we're basically going to do is we're going to take our large documents, we're going to split it up in different smaller parts that are all a bit more to the point, like different sections. There's many different techniques to do chunking. Chunking can basically be done by literally getting a certain amount of characters, but it can also be done semantically based on titles, subsections in your documents. It all depends a little bit on the data you're working with, what will work best. So that's something for you to look up to and to experiment with when building your RAG application. Another alternative, which is definitely not as popular, but is summarization. Why I think it works or can work great is because it can automatically sort of reason about the context and what is important in a document. So that's something to consider as well. It's not always better than chunking, but it can definitely be. People have come up with a lot of advanced techniques as well to improve the retrieval part. For instance, there are special re-ranking models. So instead of only getting like a top 5 documents being returned by your semantic search, you're going to get a bunch of them, like 100, and then going to ask a re-ranking model to give them a relevancy score. And then you're going to basically take the most relevant documents based on that ranking. People have also come up with things like generating hypothetical questions, because if you're going to search for a question in your semantic search, having a question is probably a little bit easier to be found when the questions are embedded in your vector database. But we're not going too deep on this. It's a bit out of scope for this talk. Let's take a look at how we do this in Beam, shall we? But maybe first, why would we want to use Apache Beam to build this flow? So we're going to build a flow where we have a set of documents and we end up storing them in a vector database. Well, first of all, Beam is really good in batch processing. So if you have a database or some kind of documentation store with a lot of documents with all of your data that you want to use in your RAG application, you can use or you can leverage Beam's batch processing to do all of that work and store them in your vector database. But data is typically not static. You do a lot of updates to your documents, you add new documentation and so on. And therefore, the stream capabilities of Apache Beam are obviously super useful. And then thirdly, there has been a lot of effort being put into Beam in regards of machine learning. Machine learning operations like run inference, they're well supported, which definitely also sets Beam apart from some of the other data processing frameworks. So let's take a high-level overview of the pipeline we're going to be looking at. So the first thing we're going to do is we're going to extract text from the documents. So documents can be PDF files, CSV files, whatever. A lot of time you will have to do some extraction of that text first, so from file to string. Then we're going to do some pre-processing. In our case, it will be summarization part. Then we're going to use an embedding model to actually generate embeddings of those pre-processed pieces of text. And then finally, we're going to store these embeddings along with some metadata into a vector database. So the first step, imagine you have a PDF. What we're going to do is we're going to extract all text. Therefore, we're going to simply implement a simple do function. There are a lot of libraries out there to do these kinds of processing. They all have their own little different way of extracting text from PDFs or from other files. It's a bit up to you to experiment what works best for you. It depends on your file structure and your type of documentation you're using. Then in our second step, we are going to summarize the original text to get that a little bit more short to the point text format that can lead to better embeddings. So what we're going to do is we're going to get the original text, send it over to a summarization model, and then that output is basically what we'll embed. To do this, I have implemented a custom model handler using the run inference API. I know Konstantin has taken a different approach in his talk. I used the run inference way because it was semantically a little bit more correct in my eyes, but there are different ways, obviously, to do it. If you're working with an external API, obviously, there are local models that you can use, and then run inference is the best choice. It's a bit up to you which models you want to use, which models you can use, which models you're allowed to use. But here we basically do some extra processing to be able to send the text to the API. Then we're going to do some post-processing of the response, and we're going to give that as a prediction result. Then a third step in our pipeline, we have our summarized contents. So we have a more dense representation of what is in the document. Then we are ready to send it to an embedding model to get that vector representation. And here again, we use a custom model handler. This time we are going to send it to a different model, an embedding model. Again, a little bit of tweaking to be able to send it to the API, and then a little bit of post-processing of the response. And then we have our embedding for that summarized piece of text. And then there's one more thing to do. So we need to be able to store all of that data in a specialized database, namely a vector database, such that we can, in our interaction with the user, we can do a search query in that database, so that will then do a nearest neighbors search of the embeddings that are all available. We also add some metadata here. I think ingestion can be useful for when you need to update your embeddings, or when you need to take into account updates of your documents. Having the original text also there is also typically easier in the later stages. When you do your search in your vector database, they can immediately fetch the text, so they can immediately pass it to your generative model to generate an answer. For this, I have implemented a custom function again. There are currently no out-of-the-box functions to do this in Apache Beam. I think this would be a nice thing to be added, especially because I think RAG is here to stay in one way or another. It simply uses, in this case, the Weaviate client. Weaviate is an open source vector database. Again, many choices in the market. You can look up any sort of comparison tables online if you struggle to find which one would be best for you. And that's it. That's sort of how easy I think it is to build like a pipeline that can automatically update or reflect your document updates in your whatever database you currently have in a vector database. And that vector database can then be used to do retrieval augmented generation. Some things to consider. We're working here with APIs. Obviously, these have API quotas. There's a huge demand for these models, so they're not always available. So it might be smart to look into some fallback mechanisms for when a model is unavailable. Also, API quota might be something to take into account. Scaling, I think there have been some talks on how to do that properly. So that's definitely something to take in mind if you're working with APIs. A little bit of bonus. So how do we actually use this in our production environments? We use a CDC architecture where we're going to store different data sources. And then we have a queue so that it's mostly separated, some best practices. But again, there have been some CDC talks I've seen at the conference. So if you want to learn more about how to do that properly there, I think you should take a look at those talks. And obviously, you don't necessarily need a single Beam pipeline. You probably have different kinds of data that needs to be processed differently, different sources, different file formats, different whatever. Each of them can obviously have its own Beam pipeline with its own quirks and features. Nothing holds you back into writing multiple pipelines. And then, the future of RAG, maybe also interesting. I think we will continue to build and make more advanced use of RAG. I think the first one is probably going to be multimodal RAG, where we're not only going to take into account text, but also images, maybe audio, video. I think people are experimenting with different embedding models, with different techniques. I personally had some good success with extracting images from documents and then sending it to a multimodal model, asking it to describe what is on the image, giving it some context, and then embedding those descriptions as well. That way, we can still leverage our text-based approach in RAG, but we can have some multimodal aspects already baked in. Obviously, ideally, we have some kind of multimodal embeddings, but those are still not ready, I think, for a lot of use cases. And then GraphRag is also something that is popping up. So instead of just having a vector database, we're going to have knowledge graphs, and we're going to leverage the connections that are in between the different nodes to also improve the quality of the answers. I think this one is also going to be growing a lot, but it's still to be seen, because obviously the premise here is that you have good knowledge graphs, which is in reality not always a given. And now we are at the conclusion of this talk. So we used Beam. Beam, super useful because of batch processing and stream processing. So batch for your existing data sources, existing databases. Stream to update or to reflect the updates of your documentation, of your documents in your database in your vector database. Obviously, Beam really good for ML. A lot of effort is being put into it. It's grown a lot, and I'm curious to see what the future will bring. And obviously, it's super flexible, right? Each rack ingestion pipeline is different. Each data source is different. Will require some customization, and Beam is definitely like a prime candidate to implement such things. And with that, I'd like to thank you. If you want to contact us, here's our LinkedIn. You can also visit the ML6 website if you're interested in our company.